we are reaching the end, then we need to go to the event's closing. So I want to introduce both our speakers. We have José Manuel Camacho Sanabria. He is from Toluca, the state of Mexico. He has a BA in Geography from the University of the State of Mexico and a master's in spatial analysis from the same university. And he's performing PhD studies in environmental sciences in the University of the State of Mexico. With us as well, we have the biologist José Luis Ornelas de Anda. He comes from the National School of Biological Sciences from the Polytechnical Institute. He is a collaborator in the Geography and Environment Coordination, and he is the Director of Natural Resources and Geography and Resources, water, soil, vegetation, everything that's themed from the Institute. And without any further introduction, I'm going to ask. At the end, we will only have 1 or 2 questions that will be available that live in the different regions of our country. The environmental issues can be seen from different analysis scales. In Mexico, we have them in all its regions. We cannot generalize in which part of the territory are environmental problems more severe, because there are factors that will change the causes and effect in the inside or outside of a region. Environmental issues that are most common in Mexico are pollution of lakes and rivers because of solid residues, liquid residues that will generate processes of eutrophisation. Air pollution, which is due to gases that are gas emissions from fixed sources. The change in land cover, which is a result of sociocultural processes mainly. The change in land cover in terrains without agricultural means. New spaces which are dedicated to land mass or agriculture and livestock systems. The impact in the crop systems, which are sustainable, caused by lesser quality products. As you know, the lack of productivity in the land, that is the loss of physical and chemical situation in the land will contribute to this impact. The loss of biodiversity in agriculture system because of chemical substances. Deforestation because of agricultural practices which aren't sustainable. Crops in lands with over 30 degrees of inclination. Erosive processes in the abandonment of agriculture spaces. And this will contribute to these processes. We have several indicators for these kind of processes. We can look at some erosion here. In this image can be seen. In Mexico, there is a social inequality, there's poverty and margination in entities which are located in the southwest portion of our country, southeast portion of our country. Environmental impact and landscape impact because of greenhouse establishment. And finally, because of plagues in forests. and I will read the discussions and conclusion in order to propose a solution to environmental problems. It isn't enough to apply principles, methods, and technicals. We also need to use other disciplines, both the field, both from the natural science fields, social sciences, and geotechnologies fields. What's important is to consider that geography, because it is an integration discipline, it allows the inclusion of other theoretical fundaments, technical and methodologic. Environmental geography is an alternative to solve the environmental issues in Mexico. And in this slide, we can take a look at the multiple applications of environmental geography, which are hydrometeorological risks, agriculture, social and organizing risks, models of territory ordaining, territorial planning, natural resources management, conservation and management of natural protected areas, the evaluation of environmental risks, solid residues managing. And I thank you for your attention.
Okay, now we'll give the floor to the biologist, Mr. José Luis. Thank you, good morning. If we can please start the presentation.
Bien, bueno, parecería no estar muy en el tema de.
Well, this is a last-minute inclusion, the topic of the natural disasters because of the things that have happened in the last month here in Mexico. Well, we all know that for Mexico's geographical position and their land, it's subject to different kind of natural risks from earthquakes, volcanoes, and the hydrometeorological phenomena as well. We were looking at the Chichonal volcano, if you remember the eruption of 1981-82, and the hurricane trajectories. So these are the risks and dangers, and the vulnerability is of course on the population, mainly due to the high growth and the location in high-risk zones. As my colleague mentioned, the loss of vegetable cover enhances these risks or increases these risks. Now I'm going to talk about what happened last month. Here we can see a modest image from September 14th where we can see both great hydrometeorological systems and part of the thing that caused the simultaneousness and the interaction between both of them. Remember, they are rotating clockwise. This interaction enhanced the amount and the intensity of the rain, and especially in the state of Guerrero. This is a few days later, Manuel as a hurricane landing on Sinaloa, and something that happened in Guerrero that also increased the amount and the intensity of the water, of the rain. If you remember, the circulation of the cloud bands and the wind interact perpendicularly with the Sierra Madre del Sur. You have this orographic precipitation. These municipalities you see here are the ones that up to October the 1st were officially declared from the SEGOB as an emergency or a disaster area. And the little stars are the meteorological stations that had over 100 millimeters in a period of 10 days. And if some of them you can see they are yellow. From day 1 to day 22, they had a greater precipitation in those days than the maximum recorded for the entire month of September. Not just the average, but the maximum precipitation that had occurred before. It didn't happen in all of them, but in some of them it did. Now we'll talk about some cases and how we can use the information we have, whether it be from INEGI or from other institutions. Other than what we already talked about that increased the amount and the intensity of the rain, the geological substrate in this area also has an impact on this. In this case, for the mass movement that occurred in La Pintada, which is a kind of granite that slides easier than most. The type of soil with a high capacity for permeability and water contention in this area, and this is an interpretation of the La Pintada town. And this is where the runoff occurred, and you can see that it is treeless. These are some pictures taken by the media and from Google Earth, so this is the before and after. I'm sorry. I think they'll be online, and here part of the usefulness of the information, both geographical and georeference statistical one. The geologists delimited the polygon of the landslide, and when they overlapped it for each block, we could see that we had 9 blocks that were affected and the number of inhabitants, and also the 9 of houses recorded in the census of 2010, so we can have a fast idea of the number of people that were affected by this. Well, the conditioning factors, it was a perfect combination. The extraordinary amount of water, of rain, the type of soil, the type of rock, the slope, the deforestation, and the landslide started exactly below the tree line. Well, we have also created the inventory of geological phenomena using previous records from this phenomenon, and as you can see, it's concentrated mainly on the south in the extremely rainy areas. El Paraíso is another town that is close by. We didn't have a landslide, but really large amounts of water. And this town has several streams that pass across it, with a very small space for these streams. And using SIAT tools, we can determine the gathering area and its characteristics. Now, the characteristics of the gathering ditch, and also something that can also be helpful in order to estimate even beforehand, in situations like this, the population of the community and certain other characteristics on the housings, the distribution of the vegetation in the gathering ditch, the normal climate change. And another way we can estimate the effects is images of before and after. So aerial imaging, satellite imaging, and they don't always have to be high resolution. These are MODIS imaging from the Conabio. This is Tampico, the Pánuco River. This was March 13th, which was very dry, and September 23rd, and you can see the flooded areas, not only the city of Tampico and Pánuco, but also all this area that is flooded. This is Acapulco, in a GOI image from September 30th, and the polygons limit the areas with apparent flood. This is a zoom in or a close up of a neighborhood which is completely flooded, and it's exactly the same area a few years before these housings were built, and we cannot really see here that it would be floodable. So this is one of the causes of the flood was the La Sabana River, and this is the gathering area. The Sierra Madre del Sur is perpendicular to the direction of the winds that were coming from in this direction south-north, and they crashed, and that created really high amounts of large amounts of water. And a little bit more about information to prevent these disasters. Well, it's a foundation starting from the hydrographics, roads, geology, soils, vegetation. We've seen this before. And for the assessment, in previous cases, flights were carried out to see what was the population that was affected, especially at a block level. Now, something that maybe we need to really reinforce is that in the hydrometeorological analysis, we need to carry out analysis focused on the basin. All the things we have heard in the lower areas, not only Acapulco, but other areas, it was not necessarily just the rain that fell on that place, but in the entire basin. This is the Papagayo River that also had very severe effects. So what else do we need? Not only to have the information, but the services as well, and to have quick access to that information. Like I was saying, we already have like an access point and an analysis point, the hydrographic network, and this also has cartography tools to upload pictures of affected areas and their location. We also need to have more services. We have WMS services, but we also need other kinds of services like WFS and also processing. We need to have services of consultations that imply online processings like these polygons to see which or the amount of population affected. Here we can see again by basin the estimation and the result for basin. Everything is done on the flight. We also expect to have the roadway network. So when we have that network, let's say this bridge is taken down by the current. So with this, we could see on this side all the towns that would be incommunicated or to have alternative routes. So in this time, we maybe had tens or hundreds of locations or towns that maybe nothing happened to them, but the communications for that place were severed. So to conclude, we need to continue developing collaboration tools. We need to look at the possibilities of social networks, and this is with a question mark, because you might see that not all the information that's there is reliable, so it's useful, but we need to be careful with this. The other thing, there's a lot of information available, and this is good, but it's not enough. It does not go into detail enough. Most of the digital recording models don't have the details in order to estimate areas that are flood susceptible. Some of them already have a LiDAR or other kinds of models in detail, but many of them don't. So, and the other one is accessibility. Many times we have the information, but we don't have the access to it immediately. It's not it's a quick access or 1 or 2 days that we have to request it and prepare it. No, it must be immediately available, completely 100% immediately, and that is at that same moment. Okay, also other sources of information, other layers that must be developed or are being developed or are not ready yet. Also, what we have been hearing these days about the possibilities of mobile devices that, like we were saying, it started with, okay, let's look at the closest restaurant, but we can also look for this kind of information in which we can have this kind of communication. And another possibility, I don't know if it was mentioned elsewhere, but it's what we call now the Internet of Things, which could be hundreds or thousands or myriads of sensors that are distributed and automatically sending energy on meteorological variables or the water flow in water currents, that actually hydrometric stations are diminished, and I would say it's urgent to re-establish them. So that would be all for me. I thank you for listening.
Quisiera agradecer muchísimo.
I would like to thank both of our speakers. They really kept the time, and we have time for a couple of questions. So I would just ask you to tell us your name and where you are coming from. Good afternoon. I'm Hugo Dalba from the ITESO, and the question is for the biologist. About quick support for disasters, is there a platform in which someone, which is a SIG expert, could interpret images in order to help in this matter? If so, where can we get high resolution imaging? Well, I think right now we don't have something that is openly accessible. That picture, that image was from the September the 30th, also because it was very cloudy, and then it was acquired and processed, so it takes time. And what we were saying, that about cartography, crowdsourced cartography is very important, and put them online, and for whoever wants it, not only official specialized people, but everyone can contribute. And the CIET has tools at least to upload pictures with their positioning. You can look for Ruben Carrasco, that is already working. You can ask for an account and so on. And another kind of image that I didn't mention when I was talking about limitations are radar. Limitations that go through the clouds, but we cannot always see all the flooded areas, just one part of it. That's why I was talking about the limitations we still have. Any other questions? Yes, good morning. Gerardo Beltrán Vázquez from Pemex Production and Processing. I work a lot with the geographical information. We produce this information, and what we usually see and we are not really doing, and I'm talking about everyone, is to prevent, because what already happened is a value to solve something, but not to prevent it. And I'm talking about everyone who manages geographic information. It's really nice to see it, but how are we using it? What's it used for? What's it useful for if we don't have a prevention system for situations? There's models that simulate how the water comes down, how things flood, how areas are flooded. But if we don't use this geographic information, then we are losing Even with social network, we are more reactive than preventive. It's just a comment, not a question. Yes, on this side. Thank you. I'm from the Faculty of Geography from the Autonomous University of the State of Mexico. Throughout these speaks we have heard in these 3 days, we have realized that we still need to create research directives that are very, very specific, and I agree with the last comment. We do have research in the universities, and you and the INEGI and I don't know who else. We have that research, but it's kind of isolated. Maybe I think we need like a forum in which we set forth these directives, these guidelines, because we have the intelligence, the intellectual capabilities, maybe technology, I don't know. But it's also just a comment, not a question, along the lines that we need to become organized. Yes, I completely agree. We have another question on the left-hand side. Good morning. I am Jofre Beltran. I come from the National University of Colombia. I wanted to ask if in Mexico you have the same thing that happens in Colombia. Well, the main questions are the peripheral areas. We have a lot of information in the center of municipalities or towns, but the places that are farther away from the government and the government offices are the ones that are least connected, where we have the most problems when it comes to natural disasters. So that's why they are also the ones that have the least communication networks, and they are on the outside, to put it in a way. Yes, that also happens here. In this case, these phenomena were so large that Senapred, I think I heard something that they call the return period for some areas in Guerrero. It was 1,000 years. So just you can have an idea of the amount of water that was there. Acapulco is a very important city, and it also had damages. But, and it's true what you were saying, hundreds of towns that were farther away, that even if they didn't have any damages, they were uncommunicated, so they don't get supplies and so on. Information we do have, even with the census. So along those lines, we don't really need more information, but they have a higher impact, mainly because of communication, and that is one of the most common things. It's been over half a month, and even in the press we start reading and looking about other new communities that we're just finding out that they are uncommunicated. Okay, if you agree, we will have one last question. Okay, one last question over here. It's just an observation. I teach geography in the state of Nayarit, and I think we cannot measure. How do we measure the amount of water that is falling? But what we can prevent is that we can make aware of the people that a lot of roadways were built and many human settlements were built in places that are not adequate. I was looking on the telly that in Acapulco they deviated a stream, and maybe 2 or 3 days it kept going on. Now the airports are all on swamps. The airport of Mexico City has a swamp. The airport in Guadalajara has a swamp. The airport from Tepic, Nayarit, which where I'm from, is also on a swamp. So we measure the risks, but by periods of 3 or 6 years, and then we create a kerfuffle on the deficiencies of the public works, even if it's on on freeways on our or on toll roads, and this do not allow that the draining from the streams would have the flux it needs, and then they propose a lower capacity to prevent those disasters. So for me, we do have the area of the disaster prevention, but we cannot see the magnitude. And it happens the same thing with earthquakes. Up until it's over, then we can have the measurements. And when it comes to the rain, it's very hard, it's very difficult. Thank you very much. Yeah, thank you. Just quickly, really, we do have technologies available that to estimate what is raining or that will rain with the radars of the National Meteorological System, and the other one that in geography we're searching for information combining data from GPS signals that have a backlog when there's a lot of water vapor in the atmosphere and the meteorological data. So, but you're right. I mean, the issue is the rest of the things. Well, thank you very much. Now we would like to give our speakers an award. In the state of Nayarit and